Hello, ladies and gentlemen. Today we're going to look at linear and quadratic regressions. All right. A sequence of numbers that have a common difference is a linear sequence. A slope is the common difference, of course, and the y-intercept is what I like to call the zeroth term. Those will determine your linear sequence. If the first set of differences is not constant or the same, but the second set of differences is constant or the same, then the sequence is a quadratic sequence or a function. All right, now let's go through and determine if some sequences are linear, quadratic, or neither, because they could be one of the three. All right, let's start with this first one. The thing you want to do is take the second term, -1, and subtract the first term. All right, -1 minus -4 would be +3. All right, then you want to take the third term, 2, and subtract -1. Well, 2 minus -1 is the same thing as 2 plus 1, which is 3. And then take the fourth term and subtract the third, 5, subtract 2, that's also 3. And then take the next term, 8, and subtract the previous term from it, 5, that is also 3. So that's a constant difference, all right? And that's also called the first set of differences, 3, 3, 3, 3. All right, and if that is a constant or the same number each time, that means you have a linear sequence. All right, so that's a linear sequence. Let's go to number 2. All right, subtract the first term from the second. 12 minus 3 is 9. And then subtract the second term from the third. If you subtract 12 from 25, that's 13. All right, subtract the third from the fourth. Okay, that would be 5, 17. All right, and then subtract the next term from the next term from that. After that, 42 from that would be 21. Okay, and as you can see, that's not a common difference. So it's not a linear sequence. All right, and what you might want to do is take the next set of differences. All right, so subtract 9 from 13, that's 4. Subtract 13 from 17, that's also 4. Subtract 17 from 21, that's also 4. And notice that this second set of differences is constant, and that's what we mean when we say the second set of differences being constants is a quadratic. So this is a quadratic sequence. All right, let's go to the next one. All right, subtract the first term from the second, that gives you 0. Subtract the second 2 from the third, 2 from 4 is 2. All right, and then subtract 4 from 6, that's also 2. All right, subtract 6 from 10, that's 4. Subtract 10 from 16 is 6. Subtract 16 from 26 is 10. Well, we can see that's not the same, not a constant difference, okay? It's not the same each time, so the first set of differences was not constant. All right, so let's find the second set. Subtract 0 from 2, that's 2. Subtract 2 from 2, that's 0. Subtract 2 from 4 is 2. Subtract 4 from 6 is 2. Subtract 6 from 10 is 4. That's not a constant value either. So this one is not, this means not linear. All right, not linear here. And this one means not quadratic. All right, so not quadratic. And at this point, what I want you to just write is neither, all right, because we're not going to do anything other than linear and quadratic. And that's just a made-up sequence. I kind of made that one up on my own anyway. All right, let's go to D. Subtract 13 from 9. 9 minus 13 is -4. Subtract 9 from 5. 5 minus 9 is -4. Subtract 5 from 1, or 1 minus 5, is also -4. And -3 minus 1, that is also -4. All right, so that is a common difference each time, all right, on the first set of differences. So this is a linear sequence. Okay, All right, now let's go to part E. Subtract 4 from 0, or 0 minus -4, whichever way you want to think of it, or 0 minus 4, that is -4. All right, subtract 0 from -10, that's -10. Subtract -10 from -26, that's the same as adding +10, which would give you -16. All right, subtract 26 from -48. Okay, that would be -48 plus 26, so that would be 2, and then 2 more, so -22, okay? All right, so you can see that means that it's not linear, so it's not linear. All right, let's find the next set of differences. Okay, all right, so let's subtract that from that. That would be -6. Subtract -10 from that. That would also be -6. Subtract -16 from -22. That would be -22 plus 16, which is also -6, and that means that you have a quadratic, okay? So that is a quadratic sequence. Okay. All right. Next, let's go to number 1, part F. Subtract 7 from 11. That's 4. Subtract 11 from 7, or 7 minus 11. That would be -4. Oops, we don't need that there. -4. All right. Subtract 7 from 12. That would be 5. Take 6 and subtract 12. That's -6. Take 13 and subtract 6, that's +7. All right, so that we know immediately that it's not linear because that's not a constant, not linear. All right, let's go to the next set of differences. Take -4 and subtract 4, that's -8. Take 5 and subtract -4, that's -5 plus 4, which would be 9. Take -6 and subtract 5, that would be -11. Take 6 and subtract -6, which would be 7. 7 minus -6, which would be 7 plus 6, which would be 13. And that means that that's not a second set of differences is not common or constant, so therefore it's not quadratic. All right. And in this case, we're just going to write neither linear nor quadratic. All right. The next problem says, for each linear and quadratic sequence found in example 1, all right, perform the appropriate regression. Now, the word appropriate is there because, all right, your calculator is not very bright. It will do any kind of regression you tell it to. It's kind of like a little child. It has to be told what to do. All right, now, let me explain something to you. When you have these numbers listed out in a sequence, the first number is 1, the second number is 2, 3, 4, 5, and so on, all right? And that's what I'm going to put in list 1, all right? I'm going to put in list 1, okay? I'm going to put these in as ordered pairs, okay? All right, so I'm going to turn my calculator on. Oops, excuse me. All right, and I'm going to press Stat. Okay, I'm going to go Enter, and in list 1, I'm going to put the term number. Okay, 1, 2, 3, 4, 5. Those are what's called your term numbers. Now I'm going to put in the values, -4, -1, 2, 5, 8. And now we know this is a linear sequence. So I'm going to go back to the home screen by pressing second quit, and then I'm going to do Stat, and I'm going to arrow to the right to calculate. And I'm going to perform what's called a linear regression. And if you look down through there, the linear regression you see is the 4. So press the 4, and you're going to have to hit Enter once, twice, 3 times, 4 times, 5 times to get it to come back and give you that slope and that y-intercept, okay? So this linear sequence is y is equal to 3x plus -7, or y is equal to 3x minus 7. And if you were to go into y equals, I'll do this for you and show you, and put in 3x minus 7 and hit enter. All right, and then go back into your table, second table setup, all right, and make your table start at 1, which I just did by going down to the bottom and going one past what was there. All right, you can see these values. There's the -4, there's the -1, there's the 2, there's the 5, there's the 8. And the next one would be 8 plus 3, which is 11, and then 11 plus 3 is 14, and so on. Okay. Now, on a linear, I wouldn't even bother with the calculator because you know that this is your slope. There's your slope value right there. And if you understood what I said a minute ago, the 0th term, well, that means whatever's under 0. So if you continue the pattern back in this direction, all right, it's decreasing by 3 in this way. So if you'll decrease that by 11, you would have -7, and that is that number right there, and slope goes right there. So on a linear, you don't have to do all that work on the calculator. You can just find that if it's constant, that's your slope. That's what x would get multiplied by, and whatever number would correspond with the 0 would be your y-intercept. That would be the b value. All right. Now on a quadratic, it's totally different. You're going to have to do your calculator. All right. So what I would do is 1, 2, 3, 4, 5, and those are already in my calculator. All right, I do believe if I go to stat, all right, and you can clear out what's in there, or you can just edit what's in there, whatever works best for you. I've got 1 through 5 over here, so I'm just going to leave that alone for a moment. Okay, and I'm going to change that first term value to 3, the second term value to 12, the next term value to 25, the next term value to 42, and the fifth term value to 63, so that I have 1, 3 as a one-ordered pair, 2, 12, 3, 25, 4, 42, 5, 63. Those are your really like ordered pairs, okay? All right, and now I'm going to do graph, or actually I want to do the regression. Let's do stat. We're going to calculate the equation, okay? All right, and we're going to perform the appropriate regression, which is a quadratic regression. Quadratic regression is number 5, and then you're going to have to hit enter 5 times, once, twice, 3 times, 4 times, 5 times to get it to calculate that regression. When you do, all right, there is y is equal to 2x squared plus 3x minus 2. There's your equation right there, okay? All right, and once again, if you were to go into y equals, clear out whatever was in there, and type in 2x squared plus 3x minus 2, and then hit enter to put that function in, and go into your table, then right across from the 1 is the 3, all right? And then 12, and then 25, 42, and 63. And of course it keeps going, but that's not necessary. Okay. All right, so we did the first 2, that linear, that quadratic. We have another linear right here. Well, if that's linear, I already know that that's your slope value right there. There's your m. What I need is, if that's the first, second, third, fourth, fifth term, I need the 0 term. So I look at this pattern. What's it doing is I move from right over to left. Well, it's increasing by 4. All right, so if you add 4 to that, the 0th term would be 17, and that would be your b, your y-intercept. So this linear sequence would be y is equal to your slope value, -4, times the x value, all right, plus 17. Or if you wanted to, you could write that as 17 minus 4x. It would be the same either way, okay? All right, now I'm going to put that in the calculator so that you see that that's correct, and that's what I recommend that you do, just to make sure everything's done correctly. All right, so let's go into y equals, and let's put in -4x plus 17, oops, not 14, 17, all right? And by the way, I'm going to go ahead and put in 17 minus 4x so you see those are the same, all right? And if you look down each column, you can see that all of those values are the same. Is that first number 13? Yes. Is that second one 9? Yes. 5, 1, and then -3, and of course it keeps going. All right, so there you go. There's that one. All right, I believe there is one more, and that's the E, which was either a linear or a quadratic. Okay, all right, because we did 1, 2, 3, and there is 4 of them that were either linear or quadratic. So let's look at this next one, okay? It's a quadratic. All right, so I'm going to, once again, I'm going to label these 1, 2, 3, 4, 5, and I'm going to go into my table. All right, let me go back to the quit first, home screen. Stat, I'm going to go into my table. I've already got 1 through 5 over here. I'm going to go 4, enter, 0, enter, -10, enter, -26, enter, -48, enter, okay? And make sure there's no other thing up there. You'll get an error, all right? And now I'm going to do second quit to go back to the home screen. I'm going to do my regression. This is a quadratic sequence, okay? So I'm going to do stat. I'm going to go to the right to calculate, and I'm going to perform the appropriate regression, which is a quadratic, and that is number 5, all right? So once you press the 5, you're going to have to enter 5 times. 1, 2, 3, 4, 5. And when you do, it'll come back and it will give you y is equal to -3 times x squared plus 5x plus 2. And there's your quadratic regression. Now, by the way, these regressions are pretty precise because I made sure all these were integer values and they come directly right out. This is not a line of best fit, all right? But if you wanted to turn your diagnostics on, let's find that catalog. Turn your diagnostics on, all right, by going into the catalog and going down to the D for diagnostics. Let me get those diagnostics turned on. Okay, diagnostics. There's off, there's on. All right, so now they're turned on. And if I did that same regression again, all right, it would give you an R value of 1 because R squared equals 1. You take the square root of each side. R value is equal to 1. That tells you that's as strong a regression as you can get. And that's how you perform a regression. All right, if you have questions, please give me a call, email me, or show up during one of our Google Meets. Have a good day. Bye.